start recording. Yeah, Miranda, you're good. You can take off. So today we're going to look at reflections in a little bit more detail. So please get out a piece of paper, something that you can write some notes on. Ideally, it would be in the same place that you took your translations notes. There's only like one page, I think, 2 pages that I actually want you to write stuff down on, and I will let you know what those are. But today we're going to look at reflections and see it's the buildings are reflecting the clouds. I thought, okay. Anyway, we're going to start with reflections across the x-axis. And like we did on Thursday, we're going to start by looking at how to reflect a single point, and then we'll talk about how to reflect bigger shapes. So first of all, to reflect a point across the x-axis, all we need to do is change the y value to its opposite. So you can either write this first bit, or you can write this second part right here if you understand what that's actually telling you. What this is saying is basically if you have the coordinates x comma y, you're going to switch it to x comma negative y. Something important to note here though is if I had the coordinates, let's say I had instead of x comma y, I had 2 comma negative 3, and I wanted to translate that into this other, or the reflected version. When I put those in, I'm going to do 2 comma, and then I'm going to have negative 3. Which is really weird. Can anybody tell me what is negative 3?
Positive 3.
It is positive 3. Right? So you can think of it as kind of just the 2 negatives come together to form a positive. So this 2 comma negative 3, the negative 3 would go to a positive 3. So you're just changing the y to the opposite value. Right? So first thing we want to do is reflect point A across the x-axis. Now point A is at the coordinates 5 comma negative 4. So we're going to translate that. The x value is going to stay the same, right? We keep our x as whatever value it was. And then we change the y value to its opposite. What's the opposite of negative 4? Just
3.5.
It's not quite 3.5. You were close though, Todd. I appreciate the effort. It's positive 4.
At least 3.6.
That's true. It is at least that much. So if we graph this new point 5 comma 4, that's going to be right here. And as you can see, we have reflected this across the x-axis. Now you'll notice that when a point is reflected across a single axis, it's going to be on the same sort of vertical. If you reflect across the x, if you reflect across the y, it's going to be on the same horizontal line. So that's just one thing to keep in mind. Now, making it a little bit more complicated, we can apply that same principle to bigger shapes or shapes in general. So if we want to reflect triangle BCD, all we have to do is reflect each point individually. So if we start with B, B has the coordinates, let's see, negative 7 comma 2. So we're going to reflect that. We're going to change the y value to the opposite. The x stays the same. So we have negative 7 comma negative 2. So this is our new B. This is B prime. Remember that when you reflect a point, the new point has that little prime mark with it. C goes from negative 2 comma 2 to negative 2 comma negative 2. So this is C prime. So we move that one right here. And then D, we can do this visually if we want to. We could just go whoop and flip this around. What you would do if you want to do it visually is you count the number of points you have to go down. So 1, 2, 3, 4, 5, 6 to get to the x-axis, and then you go that many down this way. But we can do it easier using the mathematical way. So if we look, the point is at negative 7 comma 6. We just want to change the y to its opposite. So it goes to negative 7 comma negative 6. And this is D prime. So negative 7, negative 6 is right here. Prime and C prime. See, somebody saying something in the chat. Pamela, you skipped ahead to reflecting across the y-axis. Good, good. We'll get there in just a second. So as we can see, this ends up making the same triangle that we had before. It's just now flipped. So any questions about how to reflect across the x-axis? I don't see any. Let's go ahead and try it. So what I want you guys to do is try to reflect triangle EFG across the x-axis. So what you're going to tell me is what are the coordinates of E prime, F prime, and G prime. And I'll give you the coordinates to the first ones, just in case they're hard to tell from where you're at. So point E is at the point -8, -8. Point F is at the point -8, -4. And point G is at the point -3, -8. Todd, make sure you leave the X value the same. Don't change the X to its opposite. You're reflecting across both axes. There you go. Let's see. Okay, Aiden, you're good on your first two. Todd, that is good on the last one. Dane, you forgot all your prime marks, but otherwise those are all good. Pamela, those all look good. Todd, I think your fixed E prime is also good. Aiden, I'm assuming that was supposed to be a comma, but that is correct as well. Jennifer, you switched the wrong one, so you reflected across the y-axis for all of them. Make sure you're changing your y value, not your x. Brennan, that's all right. I will tell you in private chat whether or not those are correct, Brennan. Okay, I'll give you guys about 30 more seconds and I'll start talking about them. Just a second. Okay. So for each of these points, all we're going to do is change the y value to its opposite. So the x is going to stay the same. So writing the first part is really easy. We have -8, -8, -3. Those are the x values. Those all stay the exact same. We don't have to change anything there. Then instead of -8, we're going to take the opposite. The opposite of -8 is +8. For f, we're going to take the opposite of -4, which is +4. And for g, we're going to take the opposite of -8, which is 8. So our points should look like this. E prime is at -8, 8. F prime is at -8, 4. And G prime is at -3, 8. So let's see, it should look something like this, I think. And 4. Yeah. Something like that. I think that's right. My triangle looks a little bit worse because obviously I can't draw straight lines, but hopefully you guys get the point. All right. So how are we feeling about that? Meh, decent. Should I do a scale of 1 to 5? I won't bother with it. But let's go ahead and now we're going to talk about reflecting across the y-axis. So this is the other one. Basically, to reflect across the y-axis, we're just doing the opposite of what we do to reflect across the the x. So instead of changing our y to negative, when we have xy, we're going to change the x to negative. And that'll just reflect it this way. Instead of reflecting across the x-axis, we went this way. So this time around, we're going to go left to right. So let's reflect point A across the y-axis. Once again, point A is at the point 5, -4. So A prime, A prime. What we're going to do is we're going to change the x value to its opposite. So what is the opposite of +5, everybody?
At least -4.5, I'd imagine.
That's actually not true. It is less than -4.5.
Somewhere around the ballpark.
Because you got tricked up with the negative. But yeah, it's -5. So the opposite of +5 is -5. And then we keep our y value the same. So we have -4. So -5, -4, if we go and graph that, that would be right about here. And once again, this is reflected across the y-axis. Okay, let's try this. So we want to reflect triangle EFG across the y-axis this time. And I will once again, the points are actually, they should all be the same. They are. So E is still at -8, -8. F is still at -8, -4. And G is at -3, -8. So go ahead, do your best to reflect these, and then we've got one more thing we'll cover, and then we're going to be done for today. Yeah, Jennifer, yours were all already reflected across the Y. So yeah. Pamela, you are currently reflecting across both axes. Oh, okay. Todd, those all look good. Dane, those all look good. Brennan, those all look good. Aiden, that is good for the G prime. I didn't see, did you already do ENF? Pamela, those are all good for just the Y. Aiden, that's good for E. And that is good for F. Okay, I'll give you guys about 30 more seconds on this. If you're not trying this, please at least be writing it down, because hopefully this stuff isn't actually too terribly complicated here. And I'm going to do the same thing I did Thursday. So your ticket to leave today is going to be answering the last question, which will be slightly harder than this one. So once again, reflecting across the y-axis, we're just going to change our x value in our points to the opposite, which means we can write in all the y's as they are. So we can leave the -8, we can leave the -4, and we can leave this -8. So all of these are going to stay the same. And then we just need to do the opposite of our x's. So for the first one, we have -8 as our x. The opposite of -8 is +8. Second one, x is -8 again. So once again, the opposite is +8. And then the last one, we have -3. The opposite of -3 is +3. So we can graph this new set of points. It should be reflected across the y-axis. So if we go to the point 8, -8, that would be right here. That's going to be our E prime. If we go to 8, -4, it's going to be right here. That's our F prime. And then G prime is at 3, -8, which is right here. G prime. And that gives us the triangle E prime, F prime, G prime, which is a reflection of this one here. Any questions about that before we put it all together and go to the final one? All right. Oops. So I was originally going to have you reflect this one across the x-axis as well, but we're actually going to look at that on the next slide. So to reflect a point across both axes, all we have to do now is change the both the x value and the y value to their opposite. So if you're writing out the notes like this, xy is going to go to negative x, comma, negative y. Now this time around, I gave you a different point A. So I want you to try on your own to reflect point A, which I will give you the coordinates of. It is -5, 2. Reflect point A across both axes. Good, Pamela. Good, Dane. Todd, that would be just the x-axis. Oh, wait. No, it wouldn't. That would be just the y-axis. Jennifer, that's correct. Todd, there you go. Now you fixed it. Brendan, that's good. Aiden, that's good. Jennifer, Carter, Riley, Jocelyn. Oh, wait, no, Jennifer already said something. No, not Jennifer. Take it back. Carter, Jocelyn, Riley, Asa. Yes, Todd. How did you write upside down like that? Benito. Caleb, you're a little early, I think. Yeah, you're a few. Barb, that's good. Okay. So again, this time we're just taking the opposite of both points. So we're going to take the opposite of -5, which is +5, the opposite of +2, which is -2. So this would be reflected across both axes. Now, reflecting across the axes like this is actually kind of interesting. So we get the point 5, -2, which is right here. Now, what we could do is you could think about flipping this across the x, which would put it here, and then flipping that across the y. But really, this reflection actually occurs across a diagonal. But that diagonal changes depending on which quadrant your initial point is in. So this one is reflected across this diagonal. You flip it like this. If you had a point that's over here and you're reflecting it, it reflects across this diagonal. So it kind of just depends on where the point actually is and which quadrant it is. If you're more of like a visual person, you like to think of folding the piece of paper in half, then you can think about it as kind of folding it triangular in half, I guess. So this kind of reflects like it's a mirror across these two different diagonals, depending on which quadrant your point starts in. Whoops, that was apparently the last thing. So your exit ticket today is to reflect this point, or this triangle. We'll do a triangle. This triangle across the x and the y axis, and we will call this triangle x, y, and z. So our x coordinate is, looks like 3, 7. Our y coordinate is 5, 6. And our z is 3, 5.
Clary,
Yes.
why would you make a triangle in both quadrants if you just wanted to make us reflect about?
What?
Wouldn't it be better to put the triangle in a different quadrant if you're going to
Potentially.
reflect axes?
I mean, this is fine. I don't mind. It's easy, but that's okay. So let's see. Todd, you've got 2 of the 3 points. Never mind. Todd, you're good. Dane, you're good. Brennan, you're good. Aiden, you're good. Jennifer, you're good. If I let you know you're good, you can take off. Carter, you have reflected that across the x-axis. You need to reflect it across both. Jocelyn, that's good on the X. Also, your homework for today, everybody, before you leave, I think somebody already left, sorry, is reflections on the Cartesian plane or IXL P9 and P10. So there are either two IXLs, you can get those to 70, or just one math-based assignment. The math-based is longer than the IXLs, so. Pamela, those are all good. So I'll go ahead and do X prime. Again, it depends on when the internet gets into the new building, Pamela. We're waiting on inspections and all sorts of other stuff. Carter, now you've reflected just across the y-axis. You want to do both at the same time. See you later, Pamela. So X prime, since we're reflecting across both axes, we want to take the opposite of both numbers. So we're going to do -3, which is the opposite of +3, comma. Then we take the opposite of 7, which is -7. Jocelyn, C, that point is good for y prime. So if you can give me y prime and z prime, you can take off. You're good to go at that point. I guess I can stop recording.